I'm Mel Sandells from the University of Reading, and I work on remote sensing of snow mass. Snow is incredibly important because more than 1 billion people rely on melt for their water supply, yet we know very little about where it is and whether it's changed with the climate. Current satellite estimates of snow mass rely on looking at the amount of radiation naturally emitted by the Earth at microwave frequencies, and how much that's reduced is related to the snow mass. I say current methods, these satellite estimates are so poor that currently no satellites even bother measuring snow mass anymore. And the reason they're so poor is that they assume that all snow is the same absolutely everywhere at all time. Whereas in fact it changes over time, the snow crystals grow larger and depends on the temperature history between the soil surface and the air. So we're developing a new method of retrieving snow mass using data assimilation. So we use a physically based model here to predict changes in the snowpack, changes in the snow crystals. This model, Snowball, is designed by a computer scientist, so it's very efficient, it's very nice, it's written in C, it's beautiful code, but it's quite hard to work with because some of the code is in libraries if it's shared with other things, and some of it's elsewhere, so it's quite tricky to use, but a beautiful piece of code. However, we may not know what the soil surface temperature is, so we coupled this up with a multi-layer physically based model of the soil, SURE, specifically designed to predict changes in freeze-thaw. That's written in Fortran 77, and it's actually quite hard to get those two models talking to each other. So I'm not an expert, but for me the quickest way is just to recode that with C and put it in with Snowball. We also need a third model to predict changes in to predict what we think the satellite would see. So we've got the Helsinki University of Technology, or HUT model, which predicts microwave emission. That's in MATLAB. So again, possibly for us, the quickest way is to recode that in C and couple them all together. So please come and talk to me because I'm sure there's a much better way of doing it. Now, as I said, this is going to be in a data assimilation system, so we'll use the models combined with the observations. We'll be using something called a particle filter, so we'll have lots of models running in parallel. But what this means is that for any variable that changes in each of those model runs, we cannot have that defined as a global variable. So from this nice, neat coding, we've got to rip it all out of its current format and then make sure that all the variables are in the correct format. And I'll leave it there. Thank you.